Hello students, welcome to my YouTube channel Forcetra. Myself Mudita Bansal. In this video, we are going to solve previous year IBDP paper 1 questions. We will solve 5 questions and the next 5 questions would be in next video. Forcetra, precision learning and powerful results. So contact us for one-to-one tutorials or any doubt solving classes. You can mail me on forcetra.physicss@gmail.com or WhatsApp me on this number. Or to book any session with me, you can scan this and DM me on the WhatsApp. Let's see the next question. Three statements about the atom are: the nucleus of the atom is positively charged. This is correct. The electrons provide only a smaller fraction of mass because electrons are very light, so it provides very small fraction in atom. And most of the atom is a free space where the electrons wander. So all are correct option. So 1, 2, 3 all are correct. The electromagnetic spectrum radiated by the black body at temperature T is shown a peak at wavelength lambda v. So according to the Wein's law, lambda p into temperature, the peak at of wavelength lambda p is a maximum wavelength it would emit, is equal to a constant which is 2.898 millimeter into Kelvin. So this is constant. So the graph between lambda p and t, it would be inversely proportional to temperature if you want to plot. So in inversely proportional is this graph. A is the correct option. Next question, water is to be pumped through a vertical height of difference 12.5 meter. The pump is driven by the wind turbine which has the efficiency of 50% and an area of the blades of 100 meters square. The average wind speed is 5 meter per second and the density of the air is given to us. What is the maximum mass of the water that can be pumped every second? So in 1 second, we have to find the mass. Okay. All right. So we know that the efficiency of the pump is pump output upon pump input. And the pump input is equal to half rho A V Q. Let's put all the values. So it would be half 1.2 and the area is 100 meters square and the velocity is 5 q. So when you solve it, it would be 60 into 25 into 5. So let's leave it here. Now we will see what is the output, what output we need. So the power output, we need to draw the water, right? So it would be m dot gh. This output we need, and this m dot is representing mass flow rate, but it is given we have to find the mass in 1 second. So I am writing the mass we need to find into 10 into height is 12.5 meter and we have to find this in 1 second. So this should be the power output. So can we now substitute in the efficiency formula? So it would be m into 10 into 12.5 divided by 60 into 25 into 5 is equal to 0.5. So when you solve it, it would be the mass you would get in 1 second is 30 kg. B is the correct option. Let's see next question. When heating a metal rod at one end, the thermal energy is transferred along the rod. Which statement explains this transfer? Free electron transfer kinetic energy to the ions of in the metal. So yes, it can be possible. Intermolecular potential energy increases throughout the metal. Incorrect. Intermolecular potential energy is transferred to kinetic energy. So this is also incorrect because this is not a way to transfer heat. Ions in the metals radiate energy in all direction. No, it is not possible because with this high temperature is not achieved in the metal rod. So A is the correct option. Planet X and planet Y both radiate as black bodies. Planet Y has twice the surface temperature and 1/3 of the radius of the planet Earth. So the planet Y temperature is twice the surface temperature of X, and the radius of Y is one third of the radius of X. What is the power radiated by planet X upon power radiated by planet Y? So we have to find the power radiated. So we know that the power upon area is equal to sigma into T power 4. So power is directly proportional to area into temperature power 4. So if I write for X power radiated by X upon power radiated by Y, then the area of X into temperature of X power 4 and area of Y upon temperature of Y power 4. So we can rewrite this formula AX instead of area I can write radius of X square into temperature of X power 4. And we know Ty is having this relation, so I can replace this twice of Tx power 4 instead of Ty. And this area I can write Ry, and Ry instead of Ry I am writing Rx 1 upon 3 square of it. So this is Ry square and I am replacing with Ry value. So let's solve this. It would be Rx square Tx power 4. It would be cancelled in the denominator. So it would be 9 because this 3 square 1 upon 3 square 1 upon 9, and 9 it would come in the numerator divided by the 2 power 4, which is 16. So it would be 9 upon 16. A is the correct option. Thank you for watching. Like the video, share the video and comment it. So subscribe my channel to be updated for the next video.